Okay guys, welcome back. We're doing question 11 now. So before we go there, we're going to go here, and even before that we're going to say, oh look, that looks like a quadrilateral. Let's remind ourselves of what our quadrilaterals look like. That's a trapezium. Okay, now I know we had a trapezium question earlier in this paper. It's a bit strange that they just use a trapezium twice. Okay, so WXYZ is a quadrilateral called a trapezium. All four sides are of different length. So while these are parallel, they're of different length, and that's what makes the trapezium a little bit different than the parallelogram, where the opposite sides are different length or the same length. We know they're different lengths. It's not that they could be, we absolutely know they are. WZ is parallel to XY. Well, it wouldn't be a trapezium if they weren't. And the diagonals intersect at the point P. Okay, that's fine. They're always going to intersect, and they have to intersect somewhere, so the point of intersection has been named P. For each of the following statements, tick yes, tick which is correct, true or false, etc. Tick appropriately. Correct box to show whether the statement is true or false. These are logical statements. In each case, tick one box only and justify your answer. So we do a bit of messing around here to find out where does X goes to P goes to Y, and we're going to mark it. X goes to P and goes to Y. So that's this angle here on this vertex at P. And here she comes. Wow. How are you? Hello. Okay, you're messing up my video. We're keeping going. Good. Alright, you want to be fed, don't you? But anyway, so where am I now? I get distracted. Misty, stop, we can't see. Go. Come on. W goes to P goes to Z. Well, that's up there. Okay, so there they are. Now, in each case, tick, are they equal to each other? Is the size of those angles equal to each other? Yes. So true. And justification. Now, it isn't anywhere in your table slide, so you got to know this from your geometry. The justification is they're called vertically opposite angles. So vertical based on the fact that they're at the same vertex. Vertically opposite angles. Okay? So what I'd say to you here is just take your time mapping out where these things go, because it's a bit tedious. So we're going from X to Y to P, and it's a triangle. From X to Y to P, that's that lower triangle there. And from W to P to Z, from W to P to Z is that upper triangle there. And the question is, are they equiangular? Well, we know these two are equal, but are there any others equal? So we need to start investigating. So let's think about that angle and that angle. Now, while we might be covering it again later in the year, what we do know is that when you have a transversal between two parallel lines, and they are parallel, then these angles are equal, because they're called, so you have the transversal, and they're at alternate sides of it. Okay, so and because so those two are equal, by the same argument that I just made, that's equal to that for the same reason. And the name of it is so alternate angles. This is my script, so I'll just name that as 1. 1 equals 2. 3 equals 4. And 5 equals 6 because of, as I said up here, from E. So I have angle, angle, angle condition. So equiangular. Now I'm going to look carefully at exactly how they word it, because I'm just kind of going, whoa, I'd love to see the marking scheme to say exactly. But we do know that that all three angles are equal, and therefore this just looks like a bigger version of that, to be honest with you. That's what it is. And it's the reason it's a bigger one down here is because this is longer. Now, what are the areas of the triangle? So now we got to, I'll just change colors over to red here to kind of keep track. From W to X to Z. From W to X to Z. So that'll be the kind of upper left. Upper left. And from W to Y to Z. From W to Y to Z. And that is upper right. So the areas of these are the same, true or false? So what can we say? Well, first of all, these are parallel lines, so the distance between them, the perpendicular distance, is a constant, of course, between them. Okay, and so both of these have the same base. So WZ is common base, and H is common perpendicular height. Therefore, same area. Just a very interesting thing, just in brackets, but it's not really important, but maybe not similar. Maybe they're not the same shape, maybe they're not equiangular, these two. I bet you they're not. But they are the same area, because even if one is different shape, they still have the same area because they have a common base and a common height. And we can go back, or we can go forwards or whatever, and find, sure, look, this is what it's all about. You can write it down if you want, the equation. Area equals half AH, page 9. And it qualifies as that. As if, like, if I turn that upside down there, as if like that thing there along there is the top, and you're getting one height going that way, and then another height, you could draw this along here straight with that, and another height going up here, but it's the same. Okay, that's the end of question 11. We'll grade it now, and there's only one question to go. Now we'll keep a close eye now on how they word it. Appreciate. I might learn something about just polishing up how I'm teaching you. Okay, so here we go. So we got true, and we got vertically opposite angles, and I just said vertically opposite angles. Let's say vertically opposite angles are equal. I would still give full marks, and we tend to say, well, if they know what they're talking about, if they cite the correct maths, but I just include that in future. We're going to give ourselves accept other valid reasons, but we have done it. Okay, so how many marks am I getting for this? Okay, I have to do a few things, and they're getting knitted together, obviously. So all of this is getting worth 15 marks. So the next bit is true, and we have the alternate, vertically opposite is the first thing, and then alternate and alternate. Okay, and I have said alternate angles, the first two, and equiangular, the second. I might just be more careful to say 3 equals 4 because they're alternate. Now they spelt out the angles, but I just renumbered them because it made it quicker for me and I didn't have to do spend as much effort making sure I got them right. Okay, so we will get full mark. Oh, I forgot to click. So triangles thing are equiangular. I forgot to click it's true, so that would certainly have cost me, but it won't cost you because it's all about G, so sorry about that. And driving on then, yeah, they have half the base by the perpendicular height, and they're just saying it's double. Yeah, so they did nicely here. They said it's WZ by perpendicular height, and they probably, so they put in somewhere here perpendicular height, and they said each one has an area of WZ times perpendicular height, or half WZ by perpendicular height. So I like what they did there, and I've learned, but I think I said it all as well, so we're going 15 out of 15 for that one, or it would have been a bit less because of my mistake there, but look, overall. So we're way out now on question 11, 15 out of 15, and we've one question to go, but that'll come in the next one.